When the dome collapses back, immense waves race out across the ocean. Just 3 feet high and over 60 miles from front to back, the waves travel at a blistering speed. A tsunami is born.
The energy heaved up the sea floor. That displaced vast amount of water that we can see made it its way on land. It made its way off around the Pacific.
One side of the wave takes off across the Pacific. The other races towards the coast of Japan.
Tsunamis travel very fast at a speed that depends on the water depth. And because in the deep ocean, tsunami travels very fast, reaching at times the speed of a jet aircraft.
Traveling at over 500 miles per hour, the wave takes just minutes to reach the coast. Here, the shallower seafloor slows down the front of the wave. The wave's fast-moving rear races in. It soon catches up with the front. The increasing pressure pushes the seawater up into a rising swell. 3 miles from shore, a Japanese Coast Guard crew witnesses the growing wave. The tsunami swells up as the seafloor gets shallower. Once they crest the first wave, a second one is upon them. The crew is lucky to survive. Near the coast, the swell becomes a breaking wave. It piles up. A wall of water races toward shore.
The very first thing that seems to have happened is that the sea left the land, and some of the footage we've seen shows a huge shoreline being exposed, and then the tsunami built up offshore, and the dynamics of the wave carried it inland. Probably a cubic kilometer of water just splashed landward and kept going until it ran out of steam.
This is the moment the first wave roars in. The tsunami has arrived. But there appears to be no clear pattern to when or where the tsunami strikes. First, it hits in the north. Then in the south. Then it strikes in the north again. The height and intensity of the wave varies dramatically from town to town. But why? Part of the answer lies in the varying depths of the seabed. The tsunami travels faster in deep water and reaches land more quickly. Another critical factor is the layout of the land. Cliffs, bays, and inlets along the shoreline help determine how a tsunami behaves.
It boils down to how the wave is focused and defocused by the geography or the topography of the coastline itself.
3:15 p.m. Japan time. The wave hits the town of Ofunado. Deep water off the coast here offers little resistance to the 26-foot-high tsunami wave. There is little time to get to high ground.
The best early warning system people would have had would have been the fact that there was an earthquake And people have got used to the fact that if you have an earthquake, there is a possibility of a tsunami that will follow. But in the timescale they had, there was very little time or very little opportunity for escape.
The tsunami hits Ofunado 20 minutes after the earthquake.
Water that actually hit the coast will be well in excess of 1 billion, probably 10 billion tons of water. That's a little bit like taking 1 million swimming pools and just emptying them onto the coastal areas of northeast Japan.
"15 minutes later, the tsunami hit Sendai, 70 miles south of Ofunado. The area around the city is mostly farmland, low-lying and flat. The airport here is overwhelmed in minutes.
It hits very low-lying areas. There's nothing to stop it moving inland, and so it can move inland 6-7 kilometers without being impeded.
There's not much to slow it down, and because the wavelength of the tsunami is so big, it's not going to stop until it reaches something, reaches some sort of high ground, and it'll just keep on coming.
Next, the wave slams the Miyako coast, 110 miles north of Sendai. This area has good tsunami defenses. The residents are well prepared. They should be safe. Last time a tsunami hit here was half a century ago. In the aftermath of that tsunami, they built these 30-foot-high seawalls. Tsunami drills are a regular feature of life. Everyone knows what to do when the sirens sound.
Tsunami, yeah, we're leaving. Where do we go? Go to the hill.
On March 11th, the sirens sound. The tsunami is minutes away.
You hear the sirens?
There's a hill outside of town that we're going to try to get to.
Confusion rules. Some search for high ground. Some aren't sure what to do.
Well, it's a precautionary measure, but I mean, you know, you never know. This town has a lot of history with tsunamis and a lot of death from it, so they're taking it pretty seriously, obviously.
The warning saves the lives of some.
Here it comes!
The tsunami easily breaches the coastal defenses. Miyako's high walls are useless. The tsunami is 30 feet high. So why did the 30-foot-high walls fail? Data from thousands of sensors along the coastline suggest a stunning answer.
The fact that the shoreline has actually subsided means that the sea had plenty of space to go, and it it basically filled up the empty space left by the sinking. Several villages have just been completely ruined with no survivors. And the human death toll is obviously going to be up in the tens of thousands when the final count is in.
The earthquake causes the whole coastline to drop by up to 3 feet, lowering Miyako's walls and making the tsunami much worse. All along the coast, this sudden drop in the height of the land puts towns in danger.
You've got the tsunami wave coming in, on top of what would be essentially a 2-meter higher vacuum of subsided land as it sweeps in, and there's not much to stop it until it hits higher ground somewhere.
Fukushima's shut-down nuclear power plant is exposed. There is an 18-foot-high defense wall, but the ground has sunk several feet. The wave smashes over the wall and floods the diesel generators cooling the reactor cores.
Japan, as part of its normal defenses against tsunamis, has along its shoreline a tsunami wall, and this wave of water was several times that height and just blew right past it.
The coastline goes down, so do all their power intakes, and if they have a gigantic wave coming at them, it's going to short out everything electrical.
Backup batteries take over to keep the pumps going. Batteries with just an 8-hour charge. The tsunami's destructive march inland overwhelms seawalls, erases whole towns, and sets Japan on the path to a nuclear crisis. And it isn't over yet. Now, all that water pulls back out to sea.
Huge suction as the wave retreats and drags the debris it's created on the way in, the cars, the lorries, the buses, the trains, the buildings, the people. And so they're sucked back out into the ocean.
From miles offshore, the ocean is a churning mass of currents. Huge whirlpools form. Boats like this are no match for its power.
Sadly, I think many thousands of people would have been dragged out to sea. And I suspect, tragically, we're going to find bodies washing up along the coast of Japan for some months to come.
During the night, fires rage across the wasteland. Oil from factories and natural gas from ruptured lines set hundreds of square miles of debris on fire. In Tokyo, the train system is paralyzed. Millions sleep in offices and wait for dawn. 8 hours after the quake, the tsunami wave continues to spread across the ocean. Countries all around the Pacific Rim watch nervously. In Hawaii, the Tsunami Warning Center is on full alert.
Very quickly, we realized that this was basically the first big ocean-crossing tsunami that had happened in 40 years.
Will the tsunami hit Hawaii? If so, when? And how big will it be? Readings from deep ocean.